In 2017, a paper changed everything. It gave us transformers, the architecture behind ChatGPT, Claude, Gemini. It was quite a revolution that turned language into something machines could actually understand. But 8 years later, the story might be repeating itself. Not with bigger models, but with smarter ideas. This is a story of a new architecture called a mixture of recursions, and how an AI that thinks like a traffic cop could make giant models feel slow and wasteful. Transformers taught machines attention, the ability to weight one word against another. For years that was enough: bigger models, more layers, more memory. Scale solved the problems. But scale has a cost: electricity, memory, inference time. Models got huge and the bill kept coming. Mixture of Recursions, call it a MoR, asks a simple question. Does each token needs to pass through every layer of the network? Imagine an airport security line where everyone goes through the same 100 checks. MoR says, why not let people leave earlier? Quick scans for simple travelers and extra loops for suspicious ones. The models route each token dynamically. A training controller decides 1 loop, 2 loop, or 3 loops, and so on, depending on the difficulty. The outcome: drastically less compute, a much smaller memory footprint, and inference speeds that feel instantaneous. Here are the 3 ideas that make MoR tick. Selective looping. Simple tokens exit early, complex ones loop back. A token router. Think of it as a traffic cop that directs tokens to more processing if they need it. And smarter memory. Only active tokens are cached. Finished tokens are discarded, and when memory is tight, the same cache can be reused across loops. Put those together, and 118 million parameter MoR can outperform a 300 million plus parameter transformer on most tasks. This means twice the speed, half the RAM, and less training compute. Just let those numbers sink in. This isn't just a faster model. It changes where models can run. Smaller memory and cheaper inference means powerful AI could move from massive data centers into devices, robots, and tools that need to think quickly with limited hardware. This changes the whole economics. Low cost to deploy, fewer energy demands, more privacy if the models can run locally. Google, DeepMind, and Labs didn't invent this in a vacuum. The AI's ecosystem is a race. Meta's labs, OpenAI's agents, XAI's ambitions. Everyone's testing new ideas, but MoR got the attention because it reframes the question: how should models spend their effort? If Transformers asked how much attention to pay, MoR asks where and when to pay it. Well, it's not a magic bullet. There are edge cases. Tasks that benefit from full depth context, and routing decision itself is a research problem. Tiny accuracy drops have been reported in exchange for big RAM savings. The trade-offs matter too. But every new architecture started at a trade-off. The real question is the trade-off worth it? Is it worth the change? We're not just building faster models. We're learning how to make machines choose where to think. That's a different kind of intelligence, one that is efficient, local, and practical. If MoR lives up to its promise, the next wave of AI might not be bigger. It might be smaller and smarter. If you found this breakdown useful, please let me know in the comments below. And don't forget to subscribe so you don't miss the next story about the future of tech innovation.